Yeah, so I told my host that he can introduce me as Laura. I bet I'm the only Laura in this conference, but my surname is pronounced Vuorenoja, if you want to know, so that's Finnish. I will speak today about testing, so some of the same topics that Benjamin just previously described us, but instead of interviewing a lot of people, I have interviewed only me. So here is the agenda for today. First, I will introduce to you myself and the open source project I work in. Then I present some of my views that I have for automated testing and how do we do testing in our open source project. Then we'll move on to test coverage, what it is and why you should care, how do we gather test coverage data in our project, and how we utilize that data. And then we will take a closer look into our solution where we utilize this new Go tooling for gathering even more test coverage data. So here you can see my professional timeline, some of the technologies I have worked with and the companies I have worked in. So I like to call myself as Jane of all trades, master of none. So I'm not a testing specialist per se. It's just one of the things that I hassle with. My philosophy is such that every developer should participate to testing and because the developers should have the best view on how to test the code they have written. I work in OP Financial Group, which is the largest bank and insurance company in Finland, and specifically I work at OP Lab, which is the bank's innovation unit. And my duties is to research and experiment with new technologies. And what that means? Well, the specific technology that I'm interested in is verifiable data exchange, and if you saw Harry's lightning talk just a while back, that's the same thing, self-sovereign identity. So we have, together with Harry, we have studied and researched this topic for over 4 years now. And I think that this technology will be an enabler for decentralized and self-sovereign identity. It will revolutionize the way we build digital services so that we can make them more reliable, more secure, and more privacy-preserving. So the basic idea is that different entities become the owners of their identity data instead of storing this data into the organization silos or service silos. I won't go too deep into this technology, how it works. Harry already gave you a glimpse, but I will explain some more. But first of all, this kind of decentralized domain lays out challenges for testing. So it increases complexity a lot compared to this kind of traditional where you have a single backend and the clients. So you're starting to have these multiple parties, and basically how this technology works is that each of these entities that have an identity have a piece of software called an agent that is responsible for handling their identity data. And then there is these complex asynchronous protocols that enable these agents to exchange this data. And of course there are a lot of other stuff happening, like reading and writing to the decentralized data storage and so forth. But in the end, we try to establish digital trust in a way that we don't build a direct integration from the data verifier to the data issuer. But as said, for testing, this makes a lot of complexity. We have these multiple transactions going on with multiple different parties, and also we have these asynchronous notifications that we need to react to. We have built Findy Agency, that is our open source project, as we call it. And we have published it a couple of years back, so it is the result of our research work. We describe it as a multi-tenant decentralized identity agency. So it provides this agent functionality to different kind of applications and individuals. And because we want to have more fun even, so we have laid us many different other challenges, such as creating a microservice architecture, creating many different kind of clients. So we have CLI clients, API clients, and also web application, and divided the code into multiple different repositories. How fun is that? Yet, at the same time, we are a really small team in this experimentation lab, so we do a lot of these different kind of experiments, and we usually build these experiments on top of this agency. So what we want to keep the agency code as stable as possible, so that it is not broken when we are starting the next experiment. And therefore, automated testing is the one thing that keeps us sane. And I have had sometimes some questions that, okay, hey, you are not writing this production level code, why are you doing so much testing? Well, that's the one thing that keeps us sane, so that's the answer to that. And of course, like Benjamin described a lot of scenarios in previous presentation, that was more about when you have multiple teams working on a same project. My point of view is here from a small team point of view more, when you don't have like vast amount of resources to write this kind of contract and faking code. Okay, but let's start by defining what is actually automated testing. So if you have a test script in a repository, and it's like this complete test script that is able to test your software as perfectly as it can, is that automated testing? No, if nobody ever runs it. So I think that automated testing is just those tests that are run in CI, so in continuous integration system. Otherwise, these programmatic tests are just another form of manual testing. And the basic idea is that whenever code changes, before merging the stuff to the main branch, we run the CI. This is probably a familiar approach to you. So if the tests are not passing, the code will not be merged. And I'd like to think this automated test set as an extra team member. So I like to think him as this knight against regression. So his duty is to fight against regression for us. And regression is just a fancy word for breaking up stuff that already worked. Been there, done that. So this knight, this automated test set, warns us if something is going to break, and then we will have a chance to fix these issues before merging the stuff to the main. And we have to remember that this automated test set, this knight against regression, is not a static one. So it's always evolving. When you introduce new code, you introduce new tests. And of course, whenever you are delivering a fix for an issue, for a bug, it's a good habit to add a test also for that issue, so that you won't be ending up breaking the same thing all over again. So what kind of tests do we have? Of course, unit testing is our bread and butter. And these are the tests that we run with the Go unit testing tooling, using this standard library testing framework. And they work really great if they are like this. So you don't have any external dependencies here, and you don't need to fake any external logic. So this is an example from the standard library math package, and it's a test for the ABS function. It takes one parameter, signed integer, and you can compare the result value and see if everything is okay. And this is a perfect case for the perfect match for the unit tests. And good for you if you are a Go standard library math package developer. I'm happy for you. What about the rest of us mortals? We who develop web servers, for instance. So we are starting to have these various dependencies in our code. We read and write to the file system. We send and fetch data to the network. We read and write data in a database. Our logic is dependent on time, like discussed just in the previous presentation. And of course, we are using that complex third-party API in our testing as well. But with all of these dependencies, we want to keep our tests simple, modular, fast to execute, and relevant. So we want to ensure that we are testing only the code that is written by us. There's no point testing the file system library functionality because the file system library developers has already tested that. So you are starting to create this simulation functionality. A dear child has many names. You may call them mucks, stubs, fakes, or spies. They come in different flavors, but they have the same purpose. So they try to simulate the external functionality that your code is dependent on. And this is starting to generate problems for you. You might put a lot of effort to simulate this functionality, and some scenarios are even impossible to simulate. And when you are adding this mocking code, it's more code that you need to maintain. So more work for you in the future. Also, that writing of these mocks is probably not the most meaningful line of work for you. Maybe it is, I don't know. For me, it isn't. So I'd always rather like write this new shiny functionality than the testing code. And one thing also to remember, who will then test the actual software if you are only testing with this simulation code? I hope it's not the end user who is the first one to test the actual software. And there we meet application tests, as I call them in this presentation. You might call them integration or end-to-end tests. And this is the type of testing that then complements the unit test. So when I'm speaking about application tests, I mean tests that is run in software's real environment with its real external dependencies, or at least as many external dependencies as possible. We don't use any unit test tooling for running these tests, and we run them from the end user point of view. So that I mean when I say that the software is run in real environment. So we run the software as the end user, may it be the actual individual or another system, but we run it like the end user would do. And these application tests are good for catching different kind of interoperability issues between your components, between your component and the outside world, logic that is difficult to simulate in these unit tests, and, for instance, issues that are caused by updating your external dependencies. So, for instance, if you are using this kind of dependabot or other service for doing these automatic dependency updates, it's many times good to have this kind of application test that is ensuring that the updates to the dependency updates won't be breaking up your functionality. And this is something that the unit tests might not figure out because they are using those mocks or spies or whatever. Okay, so let's go back to our project, Findy Agency, how we do testing. So, of course, our primary way of testing is unit testing. And we have some amount of simulation code and testing helpers as well, implemented with the help of the unit testing framework. And we are doing some amount of integration testing also with the unit test tooling. But the application tests help us to complement the unit tests. And typically, we run these application tests in our CI system, so we are using GitHub Actions, and with the help of Docker and Docker Compose. So each microservice is running in its dedicated container, and we are orchestrating this system in the GitHub Actions with Docker Compose. So agency is run more or less as it would be when it's deployed. And we have several kind of application tests. We are using the browser for simulating the usage from the graphical user interface, so clicking the buttons in the browser. We are using our CLI tool that we have written to manipulate our agents that are hosted by the agency. And then we have also this kind of dedicated test harness for testing our interoperability to the outside world. So our agents are speaking this protocol language with the other agents, and we have this kind of test harness that ensures that, okay, that side of things is working as it should. And one thing that is really helpful in this application test, or makes it easier for us to test in the application test, is this notifications flow. So if we have something happening in the service 4 that flows through the service 3 and then again to the service 1, and then we have a WebSocket open to the browser, and its state should update in a way that this event is modifying things. This kind of verification is really hard to do with the unit testing, but easy to do with the application testing. So this is one thing that this helps us with. Also, it helps us to verify our containers. So we are using the same Docker image scripts to build our Docker containers as we are doing with the deployment. So if we are able to verify in our CI pipeline that, okay, our container is booting up and binary is working and it's taking the settings as it should and so forth. So it gives us additional verification that our deployment time containers are working. Okay, so let's move on to test coverage. Traditionally, we measure test coverage for unit tests. So in Go world, it's quite straightforward to measure these unit tests. So coverage for the unit test. So you just add this -cover flag to your test command, and then you get some data out, and then you can convert it to HTML format and get a visualization like this. I'm not sure if you can see the colors, but this visualization now shows that which of the code lines are covered in the unit test. So the green lines are executed, the yellow lines are executed partially, and the red lines are not executed at all. So for instance, in here, we don't execute the error handling in this sample function. And this kind of using this visualization is good when you are doing local development. So myself, I use it as a personal code review tool, a way for me to improve my code quality. So if you were yesterday in Bill's workshop, he was talking about this hacking phase and this engineering phase. And myself, when I'm converting the code that is written in the hacking phase to the engineering version, I often use these code coverage visualizations. So it helps me to find out if I have missed some parts that I have forgotten to test. And also at the same time, I need to read my code. So is there something something stupid? Of course there always is. But it helps me to remember the mistakes I made. And of course, the dangerous part in test coverage, the total coverage percentage. You can calculate the coverage percentage of your whole code-based test coverage, but you should be quite careful how to use this information. Because this coverage data and the percentage numbers are not meaningful to project outsiders. And I have heard some companies use this data as their manager's bonus criteria. So don't do that. Your manager is not one of your team developers, and it's not meaningful to him. So it's meaningful only to the project developers, and it helps you to find out the blind spots in your tests. And like Benjamin stated, high percentage does not equal good test quality, because you can call a function in your test but never check its return value. So line can be covered also in poorly implemented tests. The test coverage doesn't tell you anything about the test quality. And the target percentage is dependent always on the project. For some projects, 60% might be good. For some projects, 95% is not enough. So you should always think your case and what is the target you are aiming at. Yeah, but for us, how we use that test coverage data is this automated monitoring tool. So we have integrated this automated coverage monitoring in our continuous integration pipeline. And this monitor alerts us if we have created a pull request that decreases the coverage. We are using this service called code.io. This is free for open source projects, but I think there are multiple available similar services. And this process has following step once we have integrated into the CI pipeline. So we create a new pull request. The tests are run for that branch in the continuous integration system with this cover flag on. These result files are uploaded to this monitoring service. The monitoring service analyzes this data and provides us feedback. So did the coverage go up or down? So here we have an example. So it actually places a comment to the GitHub pull request here. And here is a sample. There hasn't been a change in the coverage when the tests are run with this commit. But if there would be a drop, we wouldn't be able to merge the changes. Or at least we would need to review what is causing the drop and accept that, okay, this drop is acceptable, and then merge the changes. So I think that this approach has provided us valuable information when we are adding new functionality with missing tests. So it's good for lazy people like me, who always is like, when I get that new feature working, I'm so excited and I would just want to merge it to main so that everybody knows how cool feature I have been implementing, and I forget to write the tests. So this is an automated nagger that comes to and says to me that, hey, have you forgotten about something? And also this approach has helped us to find issues with some random test environment changes that we've had. So if our test coverage has been changing for let's say some configuration reason, we have detected with this tooling. Okay, so for the unit tests, the process is quite straightforward. So you just add these flags to the unit test and enjoy the ride. So integrate the coverage analysis service to the workflow, and it does the magic for you. But what about the application tests? You might want to monitor them in the similar manner so that your automated test set is kept in good shape, that your knight keeps to be shiny. And we have now a feature for that in the Go tooling. So Go 1.20 supports now collecting code coverage profiles for programs, application, and integration tests as opposed to just unit tests. And that means that we can instrument the binary executable, run the binary, and gather the coverage data similarly as with the unit tests. And this new feature gave me inspiration to try it out and refactor our pipelines so that this would be used also for the application tests, or that we could gather the test coverage data also for the application tests. So how it basically works is that you, when you are building the binary, you just add this -cover flag. And then you define a folder for the result files, so the coverage data files, with this Go coverdir environment variable. So after the test run, the coverage data appears here. Then you run this instrumented binary. If it's a web application, you probably just launch it, and then you run your tests against the server. Your tests may be written in any language, so they may be a Python script or a shell script, or you can use these browser JavaScript frameworks. So the testing tooling doesn't matter. And after your program execution has stopped, you convert and analyze the result files similarly as with the unit tests. So there is this cov data tool in the Go tooling that you can use for this. But as said, we are running our application test in the Docker containers, so we needed to integrate these changes to the Docker world as well. So these were the changes that I needed to do to our service Docker files. So I needed to add this new Docker build argument, which is called Go build args. And with this argument, I can now feed the new -cover variable to the Docker image build. And in the run stage, I just hard code this Go coverdir environment variable to the root folder coverage. And the coverage data can be then collected from this folder when the execution finishes. Okay, so how we are doing our application testing then? Well, we have this kind of shared GitHub action that is able to replace the service image that we are testing to our backend that we are testing. So we have this Docker composed backend which is orchestrated with this Docker compose, and we just replace the service that we want to test with this instrumented that has this instrumented version of the binary. So this end-to-end or this application test action that we are using to test these different services, it is capable of building this service image with this instrumented binary. And then it launches the test environment with this Docker compose, like described before. Then we are running the test set. So this is more or less like this basic test set that we are running for each and every microservices. This test set contains all of our core functionality. And we are running it for all of the services when we are doing changes. And after the test has been run, we convert and send the coverage file to the analysis tool, like done with the unit test data. So here is an example of the Docker compose file. Here we are using our service called Vuort. So instead of using this ready-built image from the GitHub Docker registry, we are building the service from the Docker file residing in the repository root and using this -cover argument for the Go build. And then we are mapping the coverage folder that contains this coverage data to our local folder so that we can access this data afterwards. And here is an example of the job itself. So actually the steps described before is happening in this end-to-end test action, which is the first step of the application step job. Then we get the coverage data, we convert it to a suitable format, and then we upload it into the GitHub artifacts. And why we are doing that is that we are sending both of these coverage data from the unit test and the application test at the same time to the analysis tool. So both of these testing steps now produce coverage data, and we send this data in the last step to the analysis tool. The analysis tool handles merging of this data, so we are treating this coverage data as a whole now. So we merged the unit test and the application test together. Maybe if you have a bigger team or more moving parts, you would like to see dedicated numbers for each of the testing types. But for us, this approach has been working. Okay, and when I did the change, what happened was that this coverage for this Vuor service increased by 5 percentage units. And why was that? Well, we had code that was missing unit tests. So, for instance, we had code in the main function, we had some code in the WebSocket and gRPC listeners that were missing some tests, and also some other code that is hard to simulate. And now this testing became visible with the this test coverage for these tests became visible with this application test integration. Some services had even a drop in the coverage number. So I made these changes for all of our services, and some services had even a drop because they were like totally untested files, and those became visible now in the monitoring because the application tests were hitting them. Overall, I think that this new logic improves our understanding how well the tests cover our code base now. And it has served us pretty well. Then, as a curiosity, so in this GoGov service, you can see graphs like this. So there are shiny graphs there, but quite frankly, I don't use them. So there are 2 things I use test coverage for. One is for the local test of visualizations, and another one is this automated monitoring. So these graphs don't give me anything. Yeah, so the change was quite straightforward and fun to implement. So to take this new feature in use in our application testing pipelines, the biggest hurdle for me was learn how to shut down the services gracefully. So the coverage data will be lost if the program does not exit normally. And well, the shutdown implementation itself in code is not that tricky, but the tricky part was to ensure that the Docker container passes the SIG-term signal to the container process, and there was some serious banging my head against the wall to figure that one out. So I needed to refactor some of the start scripts for our Docker containers. So if you try to do this at home, go and check our repos and see how it was done. Okay, so my takeaways today: use nights to fight regression. So run your tests in the continuous integration system for every change so that your night will be in good shape. And monitor code coverage with this automated tooling that is available for you. Again, that your night remains in good shape. Complement unit tests with the application tests. Make sure your end user is not the first one who is testing your code with the real dependencies. And remember that nowadays it's now possible to measure this coverage also for the application tests. And last, do write open source, because your life quality will improve because you get these all great tools for free, and it will make you a better developer. Maybe not so easy to implement or take in use this last instruction, but I highly recommend it. It has been fun. Thanks.
Who was the first one? Hi, thank you for a great talk, super interesting. I have maybe a couple of questions. Well, I'll start with one and we'll see. The cover flag builds it into any program. Is there a performance hit on that? What is the cost on it? And is it even possible to run this in your actual production code and then see what my users are actually covering and then maybe compare that with my test suite?
Yeah, that would be like a great idea, but I do think, I haven't found out, but I do think that it has a performance penalty, so I wouldn't use it in production, but maybe like a special case when you are doing some limited testing, but like, therefore we add this dash cover flag only when we are doing a dedicated Docker container for the application testing, and for the deployment we don't use it.
Okay, thanks.
Can you just repeat, when do you actually run the application tests? And I'm wondering, how do you handle with microservice architecture when you're making a change to 2 services in the same time for the same feature? How would you then run those application tests? So if you're doing a change on both the API and say CLI at the same time.
Yeah, in those situations, it's sometimes necessary to have the tests broken. Like for a while, we were like playing around with the idea that you could, for instance, create branches with a same name in the different projects, and when you are running the tests, the test would clone the branch of that dependent service from that branch and so forth. But it's only in the idea phase.
And are your end-to-end tests or application tests written in a separate repo, or are they contained within the same repositories where your services are?
They are having this dedicated repository.
Okay, so when you make a change to a service, you need to at the same time maybe make changes to that same repo. How do you handle that change?
Yeah, to the tests you mean?
Yes, to the test, sorry.
Yeah, well, quite frankly, I think that I haven't encountered that problem. Okay. Not yet, because our feature has been quite stable for the past months. But
cool, that's it then, thanks.
But I think it's basically, it might be the same scenario, that using these kind of dedicated branches or.
Hi, thanks for the presentation. A quick question. How long does your CI pipeline take?
Was it here? So for instance, for this for this service, the unit tests take 1 minute 20 seconds, and the application tests take 2 minutes 37 seconds. But of course, our project is quite reasonable size still, so.
Okay, that's it. Thank you, Laura.
Thank you.